Well, how cool is that? There's a lot of work to do to make this actually a reality. So I ran out to the parts sleds pile and got the shaft that the secondary clutch came off of, and another shaft basically just for that bearing. So these bearings are also retainers. So if I can make a mount that works with these on the tractor, I don't have to have an additional collar. So I'm hoping I can move these collars that way a little bit to make room for the transmission drive pulley on the inside of the secondary clutch. And hoping for the most optimal takeoff as far as smooth acceleration goes and not bog the engine down. I'm going to do some figuring and mathing and see what I get for an input speed here before I order up a pulley, because I'm going to have a 1-inch hub drive pulley. I'm kind of thinking right now just do a 6-inch pulley here and a 6 1/4-inch pulley here, because that's stock, and that'll be about a 1-to-1 drive here. But ultimately, I'd like to kind of duplicate how a snowmobile accelerates and takes off. But I have one more set of gear ratios to think of here. So here are my transmission gear reductions respectively. 66.8 to 1 for first gear, 42.4 to 1 for second gear, 24.6 to 1 for third gear, and then reverse, not like it really matters on this project, it's 51.5 to 1. But it's just good to note that. All right, I did some figuring, and let's see, where do I got? Somewhere, somehow, some way, I figured that this is going to engage around 3,000 RPMs. That's just a guesstimate. It could be less than that, which would be kind of cool if it was. But that's going to give this shaft 1,142 RPMs based on my estimated gear reduction. At maximum RPM, I'm going to have 8,000 RPMs. And that's also a guesstimate, assuming that everything's working in its tip-top shape. That's going to give me 9,333 and a third RPMs here. Also, just an estimate, but that's good to know. Which leads me to my next point. This is the last 3 rotating shafts inside the wheel horse transmission. And these are our gear sets, and this is a reduction gear, and so there's another shaft here with my input shaft, and it's spinning counterclockwise, okay? Well, one way or another, somehow, this one also spins counterclockwise when we're in forward gears, okay? So it's spinning the same way as the engine in a forward gear. And through this spinning and that spinning, this runs forward. And that's kind of what I need. I used my marker, and I just marked those teeth so I could count, and did some mathing and figured out that this one here is 11 to 44, or 14 to 44, sorry. And then this here to the differential is 11 to 43, which essentially gives me about a 12 and some change to 1 gear ratio. At 9,333 RPMs on this shaft, with a 16 to 1, plus or minus, 16 2/3 to 1, I believe, gear reduction, this tire is going to spin 50 miles an hour. So my goal is to get somewhere around 16 or 17 to 1 reduction from there to there. And my brake shaft is 12.29 to 1 reduction. And I'm liking that. So there's my shaft sticking through. I've got all kinds of room to play with. And I have more pillow block bearings, so I can run another pillow block on this side. And then right in there is the brake shaft. There's a better view of the brakes over here. So if I could figure out how to do whatever trimming I need and get a pulley on that brake shaft and get a pulley on this shaft and a belt between them, I would have only forward gears, but I would start out at about 6 miles an hour, plus or minus, and get myself up to 50. And I believe that this snowmobile engine will accelerate the tractor at a reasonable rate with the stock clutches.